All right, welcome back, guys. So, in this lesson 2.6, we're going to talk about the algebra of functions. What this saying that we can add and subtract, multiply and divide function as well. Those are the four main operations that we do with whole numbers or any real numbers instead of real numbers. Multiply and then divide, right? So we can do the same thing with functions. So remember from the previous lesson, functions are just equations that satisfy the condition where for every single input has exactly one output, right? So what we're looking at this lesson here is that how do we interpret two functions, adding and subtracting, multiplying and divide, visually, both visually and mathematically as well. So let's start with just suppose we have two graphs, right? Suppose we have the blue one, perhaps looks like that, and then we have the red one that looks like this. Okay, so how do we add these two equations or these two functions? So imagine what we'll do to add these outputs, and if we actually found the addition of these two outputs, what will the graph looks like, right? So imagine you have an x here, so let's say we have an x there, right? And then that x will give you an output here for this graph f, right? And then call this g, right? So this point here will be f of x, and then this point up here will be g of x, right? So f of x and g of x, right? So you can just look at this and say, okay, well, if I want to add these two functions, intuitively I would just add these outputs, right? For a given input, we would just add these two output and then plot that somewhere up here, right? So theoretically, we can do for all these inputs that map to these output and add them respectively to a particular input, right? So we can look at that through an equation, right? So if we know what the equation of g, what the equation of f is, we can actually add these two equations arbitrarily because x is arbitrary. So we don't have to do this point per point, right? So when we define this, we say that if you have two functions, f of x and g of x, right? Whatever the formulas what might be, or the equation might be, right? We define definition. We define the function f plus the function g at any arbitrary input x is simply just whatever the formula is for f of x plus the formula for g of x. So this is a definition. This is arbitrary x. So whatever the particular value of x given, we plug into the formula, we add them, and we get the answer, right? Same thing, we can define the difference as well, right? So it's just f of x minus g of x, and then multiplication as well. It gets a little more trickier with division, because with division we have the rule with math that we can't divide by 0. So when we look at division of functions, the rule of domain is a little more complicated to work with, and we have to consider the fact that what will be the input of x, what will be the domain in g, such that the output is not equal to 0, because we have division here. So you're probably thinking, when do we use this, or what's the point of this? It turns out we use this all the time in real life, right? When we add things and when we subtract things, and think of that in a much bigger scale. One example I can think of is, when you try and figure out the profit of something, and you have two equations, one describe the revenue, the other one describe the cost, and to get the profit, you take the revenue function, subtract the cost function. So simple as that, right? Or in sound waves, right? When you look at two different sound waves, when you're trying to amplify it, or just trying to figure out what will be the right frequency to match the sound wave, and you can add and subtract those sound waves as well. But in this class, we're just gonna focus on how to do this mathematically with concrete example, right? So that's what we're doing here. So let's look at example. Okay, I'm gonna go over several examples here. Here's my two example. So example 1, we're given f of x and g of x, and we're just gonna add these two functions at a particular input 3. Okay, so let's look at this. So example 1. All right, so given f of x is x plus 4, and g of x is x squared plus 1. All right, so if we want to find f plus g at the input 3, meaning we evaluate the function f at input 3 and add that output to g of 3. Okay, so let's go ahead and do that. So f of 3 meaning 3 plus 4 for the f functions, and then g of 3 meaning 3 going to x plus 1, and that will give us 7 plus 10, so 17. Okay, so the output for these two functions, so whatever the two functions, I can just sketch that real quick here. So let's see, x plus 4 is 1, 2, 3, 4. There it is. So that's x plus 4. Maybe longer. Oops. So x plus 4, maybe that's the graph. And then x squared plus 1, up 1. And then maybe this is, oh, let's use a different color. This is x squared, this is x squared plus 1, right? So maybe when x is 3, 1, 2, 3, you get two different outputs that add in, right? So 3 there, 3 there, and then 17 is up there, right? Whatever that is. Well, it turns out we can actually add these two equations arbitrarily like this for any input x and get the actual equation and graph that, and that graph will represent the sum function of these two functions. Okay. Anyway, so moving on to exercise 2. Okay. Given f of x is x squared minus x, and then g of x is minus x plus 2, we want to find the following. Okay, so A, we want to find f plus g evaluate at 3. Okay, so very similar to exercise 1. So let's go ahead and do that. So that means we evaluate the function f of 3, g function at 3. So we got 3 squared minus 3 for f of 3, and then minus 3 plus 2 for g of 3. So that's 9 minus 3. And that's negative 1. So that gives us 6 minus 1, which is 5, right? All right, so that's part A. Part B, we want to find the arbitrary difference function, and then also what is the output of the difference function at input is negative 2. Okay, so let's go ahead and do this. All right, part B. F minus g of x. So this is like, okay, what is the difference between two functions at any arbitrary input x? So that's just by definition, that's just taking the f function, subtract the g function, right? So f of x is x squared minus x, subtract g of x is negative x plus 2. When you're subtracting a quantity, you do have to put the parenthesis around that quantity to indicate that, otherwise we'll make a mistake with the sign. So x squared minus x plus x minus 2, the negative distribute. Right, so negative distribute to this and that. So what do we have here? We have x squared minus 2. So that's going to be our difference function, and then we want to find this different function output when the input is negative 2. So let's go ahead and do that. So negative 2 squared minus 2. So that's 4 minus 2, which is 2. Now you can find the same answer for this. Notice that if we don't have the arbitrary difference function of f minus g, you could have do this here. You can evaluate this individually and then still get the same answer. So I'll let you do that on your own. Okay. All right. I'm gonna let you do C and D on your own in homework and come back with questions in Zoom there. This is just asking to do, divide and multiply the outputs. That's all we're doing there. So that's pretty much what I want to go over in this lesson. Briefly kind of explain geometrically what it means to add and subtract two functions. And how do we do that mathematically at any arbitrary x, right? And that just take the formulas and add them or subtract them. The only thing you have to watch out for is when you subtract a quantity, you got to make sure the negative distribute, things like that, okay?